Hello, welcome to Mathematics Paper 2, 2025 GCE, Question 1. Okay, so the question 1 reads, simplify a squared b cubic of 2c times a squared divided by 2b divided by b squared c over 2a. Right, so how do we simplify this kind of equation? So it's very simple, so we just write this a squared and b power 3 over 2c you multiply by ac squared over 2b. So we first convert this one to multiplication sign, as you know how to divide fractions. So we're going to introduce the multiplication sign here. Then this one will go on top. The denominator will become the numerator, and the numerator becomes the denominator. So we're going to have 2a on top over b squared c. Alright, when it is like this, if you want, you can multiply everything on top, then you multiply everything at the bottom, then you divide. But to avoid inconvenience, you can just divide here. Alright, so if you look at 2 here, it can go with another 2 there on top. We have got c here, we have got c there, and here we remain with 1c. We have got c there, and also this is 2 will be cancelled out. What else are we remaining to divide? Okay, we have got b there, and there is also b there. So here we remain with b squared. We're going to have b squared there, and that b squared will go there. Then what else is common? There's nothing. So whatever has remained, you can multiply and find the correct answer. So you can multiply a squared times a times a. This is what has remained on top. Then I'm going to have a power 4. When you are multiplying variables, as you are multiplying, the power increases. In short, you are just adding the power when you are multiplying the variables of the same rate. Then you say over what has remained at the bottom. It is just 2, so you put 2 there, and this becomes the final answer. Alright, then let's go to question number B. For geometric progression 60, 30, 15. Right, find the number 1. We're looking at the 60th term. Find the 60th term. Number 2, or B2, find the geometric mean of 15 and 3.75. And the last one to this question is find the sum to infinite. Right, so when you are doing geometric progression, you have to know that the formula on how to find the nth term. You have to know also the formula on how to find the common ratio, and also how to find the GP as well as sum to infinite. So let us look at the first question, 6th term. So the formula that we're going to use here, we're going to use the nth term formula, which is equal to AR power n minus 1. Right, so what is nth term? We are given that it is the 6th term. Then A represents the first term. Then R, it is the common ratio. Then N, it's the nth term, which is the 6th there, which we are given. So what we are going to do, if you want, you can correct the data here. Okay, what is our first term? Our first term, according to the GP that we are given, it is 60. Then what is our common ratio? Common ratio is found by term 2 divided by what? By term 1. Now what is our term 2? Term 2 is the second term. This is the language that we use under geometric progression or under series. Now term 2, it is 30. When you divide by the first term, which is term 1, which is 60, 60 there, it is 1 over, 30 there is 1. 30 into 60, that is 2. So we have got this one, or in decimal place it can be in decimal place it can be 0. What? 0.5 or half, whichever we can use it. Then now, since we have this data here, we can easily now find what is our nth term. Our nth term is what? Is 6. So we can now start replacing the values according to the data that we have. So nth term is 6. So we say T6 is equal to what is our first term? It's 60 multiplied by what is our common ratio? It is half. Then power 6 minus 1. Right. So from there, we're going to find this T6 is equal to 60 multiplied by half power. What is 6 minus 1? We have got 5 there, so it becomes power 5. Now, last time I talked about the indices. For example, this one is a fraction raised to a power, so meaning this power will be attributed to the numerator and the denominator of this fraction. So 1 to the power 5, you find that it is 1. Okay, 1 to the power 5, it is 1 over 2 to the power 5, which is 60 multiplied by what is 2 to the power 5, it is 32. So when you multiply 60 times 1 over 32, 60 times 1 over 32. Okay, 60 times 1 over 32 is just same as 60 divided by what? By 32. And we're going to have 1.875. So to correct to 3 significant figures, we're going to have 1.88, and that is the 6th term. So this is the value for the 6th term. If you have got first term is 60, second term is 30, third term is 15, then you have to know that the 6th one, it will be what? 1.88, and that is the correct answer on the first question. Right. The second question, geometric mean of 15 and 3.75. If you are given two terms, or two numbers rather, then you are told to find the mean. What you use is GM, which is geometric mean, is equal to square root of AC, or A times C. Now, A times C, we multiply these numbers which you are given here. So, meaning the square root of 15 times, what is 15 times 3.75. Okay, so you get 15 times 3.75. So let us go to our calculator. 15 times 3.75. Okay, so we have 56.25. So it says square root of 50. Okay, square root of 56.25. Alright, so then let us look at what is the square root of 56.25. You get 7.5. 7.5. Alright, so that is our mean there. That is the geometric mean for question number B2. So whenever you are given two numbers, just use this formula, square root of multiply or find the product of those two numbers, then that will be the correct answer. But if you are given three numbers, you just get the one which is on the middle, that becomes your mean. Alright, now let us go to question number 3. Alright, question number 3, it's here, which reads, find the sum to infinite. Alright, so we want to find the sum to infinite. Now on sum to infinite, we have got two formulas. So I'll give you those two formulas and when you can use them. Right, so sum to infinite is equal to first term over 1 minus common ratio. So this is the formula number 1. The formula number 2, it is the sum to infinity is equal to a, which is the first term over common ratio minus what? Minus 1. Now, when can you use this formula and when can you use this one? This one is used when the common ratio is less than 1. When the common ratio is less than 1. For example, if the common ratio is 0 point something, the way we have got the common ratio here, which is 0.5, look at this, half. That's our common ratio here, which means this is 0.5. It is less than 1. So if it is less than 1, then we're going to use this formula. But if it is the common ratio is greater than 1, common ratio is greater than 1, then you can use this formula. If you have got the common ratio like 1 point something, 1.5, 2, 3, then you can use this formula. So now we're going to use this formula here to find our sum to infinity. So sum to infinity therefore is equal to first term is 60 over 1 minus 0.5. Okay, just say it's 0.5. You can use the decimal place if you want, which is 60 over 1 minus 0.5. It is 0.5. And when you divide this, will give you 1. Okay, when you divide this, it will give you 120. When you divide this one, it will give you 120, and that will be our sum to infinity. That is our sum to infinity. Okay, thank you for following. For more information, you can share this page so that everybody can learn. And like and comment. Where you've got a question, you can ask in the comment section. Thank you.